Welcome to our C# Programming for Beginners course. Whether you're completely new to programming or looking to expand your skills, this course is designed to guide you through the fundamentals and beyond. The course is structured into several modules, each focusing on key aspects of C# programming. Module 1, set up your environment and get familiar with Visual Studio. Module 2, start programming with basic syntax and structure. Module 3, explore data types and variables. Module 4, working with strings and more. Module 5, use flow controls with if statements, loops, and other control structures. Module 6, using functions and methods to write reusable code. Module 7, learn object-oriented programming with classes, objects, and more. Module 8, handling and debugging errors. Module 9, File I/O. Along the way, you will also learn some finer tricks of the trade to make writing C# code easier. Make sure to code along with the tutorials. Practice is key. Try out different things and experiment with the code. It's a great way to learn. Regular practice will help reinforce what you learn. Let's get started and happy learning. In this module, we'll take a closer look at strings. First, we'll quickly discuss using comments in your code. Then, we look at what happens when you mix string data types with other types and explore the more common string methods. We'll show you how to use string interpolation to plug values directly into string literals and discuss some handy escape characters. Then we'll demonstrate how to format strings, especially how to format number values. Finally, we explain how to get special characters, like a copyright character, to display in your strings. First, we'll add a new console project to our solution or create a new solution if you prefer. Remember, you can refer back to Module 1 for the detailed steps on creating a new project. Let's take a quick look at using comments in your code. You can use a double forward slash to comment out a line of code. Or place comments after or above a piece of code to describe what it does. All comments will display green. The C# compiler will ignore any commented text. You can comment a whole block of text with a forward slash and asterisk before and after the text you want to comment out. A quick trick is to highlight a block of text and press Ctrl, K, and C simultaneously to comment out the selected text. To uncomment text, select a block of commented text and press Ctrl, K, and U. To quickly delete a line of code, press Ctrl and L simultaneously. Let's look at the text data types. We're all familiar with the string type and string literals. Another text data type is char. It holds a single character, and a character literal is placed inside single quotes. We'll add an int to hold this person's age to demonstrate how strings mix with other data types. Strings aren't fussy at all. It turns out you can add strings, characters, numeric values, and literals together. A string, like the numeric data types, have methods and properties. Here, we'll demonstrate some of the more common methods of the string data type. First, let's create a string variable to work with. The first method is the toUpper method, which returns the entire string in uppercase. We can assign it to the existing variable and change its contents. We can use the string method directly in our writeLine method. The same goes for the toLower method, which return a lowercase version of the string. Then there's the trim method. This method will remove leading and trailing spaces from the string. There's also the trim end and trim start method to remove spaces from the end or start of the string. Now, a string is essentially a list of characters. I can access a single character in the string by specifying its index position between square brackets. Remember, C# lists start their index at 0, so if you want character at position 7, you need to refer to index 6. Let's see what we got so far. We get the uppercase version of the string, the lowercase version, the trimmed version of the string, and the character at index position 6. The last method we'll demonstrate is the substring method. The substring method can grab a portion of string from inside an existing string. The editor gives a helpful pop-up saying there are two versions of this method. The one we're interested in takes a starting index and a length of characters. To get the last name from the string Jane Doe, the substring will need to start at index 5 and a length of 3 characters. There's still a bug in my code. A parenthesis is missing. When it runs, it displays the last name Doe as expected. A string also has properties. The string length will return the number of characters in the string. The string empty will return an empty string. While you could just assign an empty literal to the string, it's better programming practice to use the string empty property. When running our app, we see the string Jane Doe contains 8 characters, including the space character. Because of the dynamic size of strings, they are immutable. This means that every time we change the value of a string variable, a new variable is created in memory to store the new value of the string. The impact when making just a few changes to a string is not noticeable. However, imagine making hundreds of changes to the same string variable. That would mean creating hundreds of new string variables. There is a more efficient way to handle many changes to a string variable. Here we created a simple demonstration of a string variable that gets several string constants added onto it. Again, the impact of just a few changes like these is hardly noticeable. But imagine this on a much larger scale. To solve this problem, we use the string builder object. The string builder object is mutable and can be changed without creating new variables in memory. Its two most common methods are append and append line. The append simply adds to the string without a new line character, while the append line will add a new line character after adding the string. Then, in line 20, when we want to see the final string, we can use the toString method. String interpolation is the ability to plug values directly into a string literal instead of adding values together to make up a string. We'll define two strings, a first name and a last name variable. The previous way to display the full name was to add the two strings together and maybe add a space string in between. With string interpolation, we can use the values of the two strings directly in a string literal. First, we need to start the literal with a $sign. Then we place the variables in curly brackets inside the double quotes. Note we left a space between the two variables. We can do the same with other data types. Here we'll define an int to hold an age value, then plug it directly into the string literal. Let's have a look at the output. You can use string interpolation anywhere you're defining a string. Here we'll define a full name variable and use string interpolation to construct its value. Since full name is already a string, I don't need interpolation to display it. But what if I want to display actual curly brackets when using string interpolation? Since the curly bracket now have special meaning, I need to use two curly brackets to display one curly bracket. Notice the editor displays these in yellow. Escape characters can be used inside literal strings to change the output of a string. For example, to output a blank line, we could have used an empty writeLine method. But with escape characters, we can simply add a \n to leave a new blank line after the string. All escape characters start with a \. Here we use the tab escape character to leave 4 spaces before the text. The double quote and single quote have special meaning when defining literal text and characters, so we need to escape them as well. and of course, the backslash itself. Let's look at the output. Here's a list of C-sharp escape characters. The first group is more commonly used. In the second group, we get escape characters like backspace, which will remove the last character in the string. Other escape characters like the form feed /f is more applicable to older terminals and printers. Not listed here is the \a escape character, which will give a system alert beep. You can try it for yourself. The string data type has a format method that allows you to change the way a string is displayed. In this example, we define two strings to demonstrate the strings format method. In line 10, you can see that the format method can take several arguments. The first argument is a text literal describing how the string should be formatted, and the second argument is the string that must be formatted. The formatting text contains curly brackets with two values. The first value is the number of the argument to use. Here, str0 is the only argument and is indexed as argument 0. The second part of the formatting string is the value 20. This says make the string a fixed length of 20 characters and align it to the right. In line 11, we pass two strings into the format method. In the first curly brackets, we format argument 0, or the string str0. This time we say, make str0 a fixed width of 20, but align it to the left, indicated by the negative value. The second curly brackets pertain to argument 1, or string str1, and it says, make it a fixed width of 20 and align to the right. Let's see what the output looks like. The first line displays the text with a fixed width of 20 and aligned right. The second line displays the first text with fixed width of 20 aligned left, filling the remainder of its width with spaces. Then next to it is the second string aligned right, also with a fixed width of 20. Formatting numeric values for string output is very important when displaying values to the end user. C-sharp data types have a toString method. For the numeric data types, we can use this to tell our app how the value should be displayed. Let's take a look at some of the standard numeric formats. Here we defined a double variable with some arbitrary value for demonstration. In line 11, we use the variable's toString method and pass a C to the method, telling it to turn this value into a string that displays as a currency. Line 12 uses an E format with a number. This will turn the value into a scientific or exponential format and display 5 digits after the decimal point. Line 13 will turn the value into a fixed point with 2 digits after the decimal point. Then, line 14 formats the value as a standard number output with 2 digits after the decimal point. Depending on your machine's culture setup, this may use commas or spaces for the thousand separator. Let's look at the result. Note the first line displays the value in currency format using the machine's culture setup. The next line displays the exponential format with the 5 digits we specified. Notice the number format also used the comma thousand separator as per the current culture setup. We can also do custom formatting of numeric types. In line 12, we use the toString method again, but here we specify our formatting string as 0.00. Here it says display whatever is in front of the decimal point and then display 2 digits after the decimal point. If the value has no decimal point digits, it will still display 00. Line 15 uses the hash character as a placeholder. In this case, it will only display a digit if there are any available in the value of the variable. In lines 17 and 18, we go back to the format method to specify a fixed width for the numeric values. The format string says use argument number 0 and make it a width of 15. Then also display it with 2 digits after the decimal point. This is handy when you need to display values with all their decimal points lined up. Let's look at the output. The first 2 lines' values are displayed with 2 digits after the decimal point. The third line that used the hash placeholder dropped the 0 and only displayed the digits with value. The last 2 lines with fixed widths neatly displays the values with decimal points aligned. We can use special characters in our output. There are two common character sets, the ASCII characters and the Unicode character set. All characters have a numeric value. For example, here in lines 10, 11, and 12, we cast the values 65 to 67 to character types. These values represent the letters A, B, and C. You can either define ASCII characters like this, or use the cast directly inside your string. ASCII is an acronym for American Standard Code for Information Interchange. It has 256 characters represented by byte values 0 to 255. In the ASCII table, characters 32 to 126 are your usual reading characters. Character 32 is the space character, but not all characters are display characters. Character 8, for example, is the backspace, and character 13 is enter or return. Nowadays, we prefer to use the more modern universal character set, or Unicode. Unicode contains up to 140,000 characters from different languages around the world. The first 128 characters are the same as those in the ASCII table. To use Unicode characters, we can use the escape character /U followed by the character's hexadecimal code. Alternatively, we can cast the hexadecimal value to a character by using a 0 and X before its hexadecimal value. Here, hexadecimal value 00A9 is the copyright symbol, while 263A is a smiley face character. Thank you for watching this module of the C# Beginners tutorial. We hope it was informative and educational. Should any of the concepts not be fully clear, please go back to the relevant section and watch it again. To continue on the course, check out the links below in the description for the next module. Remember to click the like button and subscribe to our channel to stay up to date with the latest new content at Learn with James.